Now, one thing, there's a term that you're going to be coming across and also calculating in this lesson. It's energy efficiencies. And every time we use energy, some of it is transformed. Some is transformed into what we want, the useful output energy, and some is always lost as heat or other wasted forms of energy that we didn't want through our device. So understanding these energy efficiencies is one way that we can improve the energy efficiency and reduce our energy consumption over time. It's one of the opportunities for us to help reduce our energy consumption is using energy efficient devices. Okay, your energy efficiency formula below here is on page 1 of your data booklet, and we're going to use it to calculate and compare the energy efficiencies between different devices. And it's a pretty straightforward formula. You're going to be putting in the useful energy. That is considered the output energy from the device. Okay. And the energy put into the device before the transformation would go on the bottom. So let's just look at a few of these examples of inputs and output energies for devices. So for example, a light bulb, its input energy, well, you're going to plug that light bulb in the wall, in the lamp. So your electrical energy is your input. The useful output energy, so remember, useful output is the visible light that it creates. So that's our useful energy. Now, there's a lot of waste energies for a light bulb. So there could be a lot of non-visible electromagnetic radiation because you have electrons moving around. Like one of those would be heat. If you touch a light bulb, you could burn yourself depending on the type of light bulb. But there's going to be heat given off, and that would be considered a waste in this case. Okay. So if you were given information about an electrical light bulb, the input energy would be the amount of electricity that light bulb used. So it would go down below. And then the useful output energy would be the amount of visible light that light bulb puts out. And then you divide the two and then multiply by 100 to get your percent efficiency. So a car engine is another device that you can calculate efficiency for. Your input would be your gas, which contains chemical energy. And then the useful output energy is the motion or the kinetic energy that car has. There's lots of different wastes. There's sound energy. Thermal energy is probably the biggest one. When you touch your car engine, it's hot. You don't be touching that, right? That is definitely wasted energy. So there's a few more input-output energy conversions in this chart. Take a look at, make sure you understand that. Hint, big hint here. A device can never be 100% efficient. So the output energy, okay, the desired output energy will always be smaller than the amount of energy you had to put into it, right? Because there's always going to be some kind of loss. All right, let's try a practice problem here. Practice problem number 1, calculate the energy efficiency of a water heater that uses 200 joules of energy to increase the thermal energy of the water by 55 joules. Alrighty, so let's take a look here at this. This is our 200 joules of energy is how much we had to put into the heater. So that is going to be our input energy. Okay. And the output is what is the work that it did? What did it do? It heated the water up to this 55 joules went into the water. So this is going to be our output. I don't know what happened to the other 145 joules of energy that was lost in this transfer, but it might have gone even as heat into the air. It just didn't go into that water. Okay, so we're going to take our formula on page 1 of our data booklet, percent efficiency. Efficiency is equal to the output. It's always output over input. So the output is 200. Oh, sorry, my bad. Oops, not 200. You can label it right. Our 55 joules is our output over 200 joules, our input energy. So I'm going to pop to the next slide. We said the calculations have been done for us. So we have our output energy over our input energy, and we're going to multiply by 100. We only have 2 significant digits in our question, so we can only have 2 significant digits in our answer. So make sure you round up that 27.5% to 28. So this device was only 28% efficient. That's pretty not good. That's a lot of wasted energy, right? That means 72% of energy was wasted. We can find more efficient devices than that. Let's hope. The next question is the same idea. I'm not going to go through this one, but definitely take a look at it. It's exactly the same kind of question. You just have to be able to identify which was the output and which is the input energy and pop them into your equation. This next one is slightly different because if you can see from the question, you're getting the percent efficiency. If an automobile engine is 20% efficient, calculate the useful output energy from gasoline containing 44.5 megajoules of chemical potential energy. Think about that for a second. Alrighty, so we have 20%, so we know the efficiency already, right? We've got the percent efficiency, and we want to calculate the useful output energy from the gasoline, and we know the input energy, so this is our input. So I'm going to use the next slide. The formula has been set up for us, and the numbers have been added. So let's take a look at what's happened here. So we have our formula where we have put in our input energy of 44.5 megajoules. We know our 20% efficient. Our engine is 20% efficient. So we've set up our formula. How did this get solved? All right. How did this get solved is the question. So you need to get rid of this 100 times 100. So to get rid of the times by 100, you are dividing this side by 100. And therefore, you're going to have to divide the 20 by 100. Okay, when you divide 20 by 100, you get the 0.20. And then the 100 is gone from your equation on this side, on the right side. So you're left with this calculation here. So not sure how to do this, how this next step happened. This next step happened by multiplying by the bottom number here to get rid of it, 44.5. And if you do it to one side, you got to do it to the other side. So you're going to multiply both sides by 44.5. And that'll leave X on one side and your answer of 8.9 megajoules on the other side. Now, because the answer didn't specify joules or megajoules, you were able to keep the units you were in. As long as your output and your input energy are in the same units, you're good. So if you're putting one type of units in, that's what you're going to get out. They just have to be in the same units. Okay. Alrighty, that is the end of this lesson. There was quite a bit of information in here. I hope you take some time to go and explore some of those interactive charts and do some of the practice questions on efficiency in your practice problem.